Hi, my name is Kelsey. Thank you for the PNW Scala guides for having me here. I am a Scala programmer. I've been working in Scala for about 2 years. Right now I am doing cool stuff with words and with various Scala frameworks at Reverb, formerly known as WordNick. I have swag if people want to come talk to me afterwards. And that's where you can find my extremely infrequently updated blog, and that's where you can find me on Twitter. And feel free to tweet about this talk, unless you don't like it, in which case maybe just keep it to yourself. So I am, that's my sweet van. I spent 2 months this summer traveling across the country with my husband in my van, and I wrote this talk in the middle of it. So the slides are van and road trip related, and if there's a mistake, it's because I wrote it in a van. So that's my deal. I'm curious, and Evan asked a little bit about this, what folks' experience is with Scala here. I mean, how many people here use Scala at work? Okay, that's a lot. That's more even than a lot of things. How many people came from like a math or FP background to Scala? Fewer, yeah. How many people came from a Java background to Scala? Imperative background to Scala? How about a dynamic background to Scala? Anybody? All right, this is a pretty diverse group, which is cool. I want to talk a little bit about where I came to functional programming in Scala from, and this was basically my introduction to functional programming. The interview for my last job, they said, so do you have experience with functional programming? And I said, well, I like to think my code usually works. And they laughed at me. And then they asked me 45 minutes of questions about lenses. So, you know, I'm usually very much like, functional programming isn't intimidating. It doesn't need to be intimidating. It can be warm and fuzzy. This is something you're already doing. But I really do get it. It can, in fact, be extremely intimidating. And I still don't really know how to use a lens. I'm getting better. But, you know, they saw enough, I guess, and they hired me, and I was thrown into work in this Scala code base. And like many Scala code bases, it was varying levels of sort of functional programming functional. But basically what that means is that my first encounter with most functional programming principles and concepts came actually in practice with production code. So that is not going to be uncommon, right? That might be different than some of your guys' experience. It's definitely probably different than Paul's experience, for example. But I think as Scala and other functional languages gain more of a foothold, that's going to be more and more common. Being into math, being into theory is awesome. Being an early adopter is awesome. It doesn't describe the grand majority of programmers. And so I think that if we're pushing like the adoption of these languages in the workplace, and we want to get paid to do these cool things, we kind of have to sort of make things viable for people who are starting out like I was, not knowing what this was, not necessarily at that point caring what that was, and wanting to be able to be functional in the sense of writing working code right away. So this talk's goal is to ground some common functional data structures in equivalent imperative code. I'm using object examples that involve a lot of object modeling, impure, unclean. But I want to show that it's not all or nothing, that a lot of times we can get these really concrete and immediate benefits in maintainability and stability and safety from introducing functional concepts, and without like having to throw out all of our current models and ways of thinking about them. It's sort of like, the conclusions, which are that like, these are awesome structures, this language is safer than what we're currently using, are probably old hat to you, but by walking through that process of how I got there, I want to sort of shed some light on that conversion process to get people to be cheerleaders for this kind of thing. So this is idiomatic Scala. This is a kind of thing that you would see everywhere. We call this a for-comprehension, or we call it a for-yield. I usually call it a for-yield. I'll say a for-yield mostly in this talk. What's going on here? Well, nothing, obviously. It's fake code. But the benefit of it is that it's fairly easy to guess, like to read it out loud almost even, to see what's happening, right? We get one value, we pass it to another function to get a third value, and if that third value is true, we're going to return some final transformation of it, which is a good start. It does invite a lot of questions. What are the types? Why is it wrapped in this for-yield? What happens if it fails? Which are all really good questions, and like the answer to almost every good question, the answer to all of those is it depends. The first question, what are the types? You can use a lot of types in a for-yield. I'm going to start with list. Hopefully we all know what that is. So, iteration over a list. Let's talk about it. This is not anymore how you do this in Java. It's how I learned how to do it in Java not very long ago. It's straight out of C, right? You got your index, and you increment it, and you iterate over. Coming from a functional perspective, there's a couple changes right off the bat I want to make to this code. The first one is that it's side effects. It immediately prints a line and then moves on, and that's sort of in the ether, and there's nothing I can do about it afterwards. So I would move that out, right? And so that's what I've done here, and I've used an object-oriented approach to do it. I actually wanted to make, the second improvement I wanted to make the list of states immutable, because immutable data is a really good functional benefit. Has anyone done that recently in Java? It's really hard. So I didn't do it, but I would like to. Yeah, I was like, oh my God, I'm having flashbacks. The other thing that jumps out at me here, like if I have my functional hammer and I'm like looking for nails, is that this is really, really boilerplatey. I mean, yeah, I did just kind of expand it, but like even the stuff that was in the last slide, there's a lot of code there that I don't actually care about. It makes me want to abstract that repeated code away, and the repeated code here is the for loop. There's a couple reasons why. One is that I'm kind of lazy. I don't like typing things out over and over again. I think it's ugly. Aesthetically, it displeases me. But the more important reason that it's safer. Has anyone ever fat-fingered a for loop? Raise your hand. I actually didn't do it here on purpose when I initially wrote this code, but I did. I screwed this one up. I start at 1. We never get a postcard from Arizona. So I would rather write that code once and make damn sure it's correct, test it out, and then never ever write it again or think about it again. So what I want to do is abstract out what changes about this code, what makes it specific to my postcard sending method, and everything else file it away in an abstracted out method. And the part here that changes is really lines 11 through 13. It's just that one expression, right? Everything else is a really bog standard iteration over a list. So what we can do is we can take out all of the iteration stuff and put it in a function, and we can take out that 11 through 13 and what that does is it takes a postcard, or it takes a state and it returns a postcard. And so I want to take that out, and you say, oh, an input and an output, that's a function. Nice thing about Scala, it's a first-class functional language. So we can write a function that does the list iteration, and we can have it take a function that writes a postcard. And that's going to be safer than what we started with. So let's do it. Split it out. I switched to Scala, lack of return, etc. On line 14, that's actually not legal Scala. It just didn't fit. So we've got a benefit of abstraction here. We could use this particular version of map over and over again, right? We could be like, hello from Arizona, I hate you. And be pretty sure that that would work, and you'd get that postcard, assuming we tested the first one. Of course, let's get more abstract, right? We use generics. We could map over any list of anything and turn it into a list of something else. Here it's generic. If we were like writing a programming language or something, we could define this on collection parent class. So you could do this over a set or the values in a map or something like that. I want to point something out here. I think, again, Paul could back me up. This isn't how Scala defines map because it's terrible. This is a terrible implementation of map. Thank God Scala doesn't define map like that. I don't have to know how Scala defines map, which is really nice, right? I get the benefit of someone much smarter than me having defined it, and I don't need to know anything about what goes under the hood. And if someone comes up with a way to do it that is faster or less crazy, they can do that, and I get the benefits of it immediately without changing my own code. That's cool. And I think this is a really good, solid example of a benefit of functional programming. It's a really good balance between configuring what we care about, which is this inner method that, sends a postcard, the actual code we're writing, and not caring about the mechanics of everything else and abstracting that away. So I think that's pretty cool. If we've written our example here to use map, I've passed this in as an anonymous function, makes life a little easier, safer. That's nice, right? I think that's an improvement to get the same effect here. I would argue it's safer. I think it's easier to read. Map, it gets very easy to read. Once you've seen it a few times, you know what it does. What does it have to do with ForYield? Well, what happens? Yeah, I don't know about your family. I'm not getting away with sending one postcard per state. I've got a list of people I have to send postcards to, right? So I've got this standard nested for loop. This is class 2 in lists 101. We saw how to convert that one call into a map, right? Well, let's do it again because we'd save ourselves all that boilerplate. Okay, That's better, I think. It's shorter. It has one tiny little problem. It doesn't compile. Who knows why? Does everyone know why? It's a list of lists. Because we go through, and for each item in the list, we return a new list. So you get a list of lists, which isn't exactly what I want. Thankfully, there's another method defined on collection called flatten. Flatten takes a nested thing like that and turns it into one collection. So there we go. That's a functional way of doing iterations over a list. Let's compare that to what we started with, right? I don't know, right? Okay, like arguably it's safer, but it's not. It saves some lines. It's not like super mind-blowing. Certainly not something you would get out of bed to be somewhere at 9 a.m. to see a talk about, right? So it also kind of like, and if we want to do another loop, we have to add another layer of map to around this whole thing and then get another call to flatten. But wait, this is a functional language. If we have two functions where we often pass the results of one to the other, we can compose them into one function. I love this drawing for some reason. I don't know why. It's like, I want to get like a tattoo of this functional. I want it to be a GIF. I want to get a tattoo GIF when we live in that like cyberpunk dystopia world where you can do that. That's my first one. That's function composition. It's just two boxes and you make it into another box. Flatten compose map is a method called flat map. And Clint kind of alluded to this earlier. Flat map is magic. Flat map is the best thing in the world. Why? Okay, the answer that's relevant to this talk is that flat map lets us use a for-comprehension, which is why I'm here, why I'm talking to you right now. So when you have flat map, you can use a for-comprehension, which means this series of nested calls can be rewritten as this. I think this is like infinitely more readable. The amount of crap that I need to ignore from this to this just like is crazy high. There's so much less cruft there going on. What's really cool is that it's very easily extensible. So let's say both me and my husband have to write separate postcards to all of our relatives. Boom, you add one more line and you've got that. You get that for free. That's kind of cool. So if, God forbid you do need to send more postcards, what happens here is that this last left arrow in line 9 gets translated to map. Everything else is a flat map above it. And that's how for-comprehension works. It's a syntactic sugar for a series of calls from flat map to map. What else can you do in a ForYield? You can do an assignment, which is just a map. Sometimes you actually do want a list of lists. You might need that particular functionality, and an assignment there in line 8 can do that. And you can do a filter. Filter's a predicate. If it doesn't pass the predicate, it doesn't end up in the final list. You want to be careful with that. Yar, there be danger there. But you can do that, and sometimes you do want to do that. That's pretty cool, but like, is a cool syntax for list really justification for changing to a whole nother language? Not so much, right? So like, why bother? Well, like, spoiler alert, it's not just for lists. You can use ForYield for a lot of different types. What can you use it for? I'm going to get to that, but I want to answer that question with another question, which is what happens to this code if one of these lists is empty? If we unsugar it back, not even unsugar it, if we untranslate it back into our nested yield situation, right? It's equivalent to this nested loop, a ForYield. What happens here if like you don't have any relatives? That's sad. And we just stop at 9. We stop at 8, right? We don't get into the rest of the loop. Or I'm sorry, we stop at 11 there. No matter how many travelers you have, we don't get into everything after 12. We don't create a new postcard. None of this code is executed. It's just, it doesn't get to there. And the same thing happens here. If we don't have any relatives, the execution's gonna stop after line 9. We return an empty list because we have no postcards to send. And we don't evaluate 10 and 11. We don't evaluate 13. And this is pretty interesting. And we could probably use this to our advantage, right? Because sometimes there's code that you don't want to evaluate. It's too expensive, or it may not be relevant. Here it's just not relevant, right? So I've written up a little, like, using this idea, a little dinner recipe plan here. And what I've done here is I've used lists to do this, right? And I know that in my ForYield, if any of those are empty, if I can't get charcoal, if I don't have any meat, I'm not going to get to the part of lighting the barbecue, because why? It's readable. It's more readable than a nested list of checks, right? Let's be real, though, it kind of sucks. Like, first off, like, what if there's more than one value returned from get meat? Like, what if I have hot dogs and hamburgers? What am I going to do? How do I know that I need to check if it's empty? I'm depending on people reading the comments, which is always the worst strategy, as I'm sure we all know. So what's the solution? The solution, as it often is a type. Option is a collection that can have 0 or 1 values, basically. It's basically this list of charcoal. It either has charcoal or it has nothing, or it's an empty list. Works the way you'd expect it to. And that abstracting away that we did, where we abstracted away the mechanics, the boilerplate of list iteration, is being applied to a different task here. So no one does what I just described. Like, this is so patently a bad idea that no one does this. No one does a check of a list as empty as a marker of whether they should go to the next task or not. However, if you're a Java programmer, you've done a lot of this, right? It's the worst. It's the worst. MPEs suck. They're the worst. This is cluttered. This is fragile. So we just don't use null in Scala, right? Like, problem solved. Or we all go home. No. Sometimes, though, like, the problem is, if you don't have null as a concept, sometimes things really are nothing. Sometimes you don't have any charcoal. What do you do then? Finding in a list is a really common example of this, right? Like, give me everyone whose name starts with X in this room. There might not be anyone, so I want to return nothing. Or an operation could fail, too, and we don't want to just leave that to the wind. So we wrap those in options. That's how things that could be nothing, we wrap in options, how we avoid NPEs. But the problem is that this is not any better. Just doing that check everywhere is not any better. The reason why options matter at all, why they're even remotely useful to us, is that map and flat map and filter are all defined on option. And so they work how you would expect them to work on a list of one item. You can map over them, you can create a new one, and then you can flat map over them in case you're doing an operation that also could return a list, and you can filter on them. So just like our list example, this will just halt. If we can't get any of these steps done, we're going to give up, right? And this whole thing returns an option. Possible dinner is an option of dinner. And that's kind of cool because then, depending on what your plans are for the evening, you can take that option and you can use it in another ForYield. You can map on it directly. Or what I've done here is you can fetch the value and provide a default if it's not there. That's pretty cool. It's the composability that you get with this that's really powerful. So ForYield is awesome. What else can go in a ForYield? Absolutely anything you want. The Scala compiler, when it's desugaring a ForYield, or compiling a ForYild, I just like saying the word syntactic sugar, I'm sorry. Doesn't it sound good? Like when you tell non-programmer friends that, they're like, oh, yummy. So when the Scala compiler encounters a ForYield, it checks the type in there and it says, does it have map, does it have flat map, does it have filter, cool, go crazy. So you can implement those on any type or a wrapper around any type, and then you can go ahead and use it in a ForYield. What I just said is technically true, and if you do it and release it into the wild, people will yell at you on Twitter. Why will they do that? Why will they do that? That's a complicated question, but the root of it. So, the class of things that can go in a ForYield is called a monad. The reason why I don't want to actually use that word, raise your hand if you've Googled what is a monad. Okay, yeah, it's like, I mean, it's a cottage industry. Look, it's like, it's not a burrito, it's not a superhero, it's not an elephant. Burritos and elephants and superheroes are cool in and of themselves because they're delicious, or they wear a sweet cape, or they have a crazy weird long nose. Monads are cool because we can use them in ForYields. I mean, that's an oversimplification, but like, as a beginning to intermediate Scala programmer, that's the point of monads, is that you can use them in this really cool data structure. What is a monad? A monad is a thing that can go in a ForYield, that's all it is. No, okay. A monad is something that implements map and flat map. Filter can be derived from those two, but Scala has you do them separately. There's a couple other rules about monads that do matter here, hence the getting yelled at Twitter. Well, they don't matter. They matter on Twitter. I mean, they matter, but they're not enforced by the compiler. That's where that gap between compilability and math is where the yelling on Twitter happens. They're not complicated, actually. It's associativity and identity. You can go learn you a Haskell for greater good or whatever, and it's not, you should follow them if you're writing your own, but we can totally use these guys really extensively and really effectively without getting into the guts of what is a monad, what is an endofunctor, blah, 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 right? I mean, list, we've all used list, and I used list for many years without ever knowing it was a monad, and I did not suffer for it. List and option, though, are two really common ones in Scala, and we have some other ones that we use a lot. And I'm going to go over a couple more of them to point out some more things about M words. Okay. So, with the option code, we were doing lookups that could return nothing, right? Sometimes, though, when you like a failure to return a value is it's actually, you might call it an error. Exceptions generally are how we handle this imperatively. We'll throw an exception if something isn't working. They like totally interrupt the control flow if something goes wrong, which is icky. Oh. I also kind of think they're rude. I think they're kind of rude because the code that calls those methods, if it doesn't explicitly recover from them, like the code that calls it has to deal with it. It's passing the buck. I don't like it. So like whatever, it has to deal with the busted van, and that's kind of not cool. So what if instead we had a container that could either have a value or an error message, which is basically like the result. Anyway, this is try. Speaking of getting yelled at on Twitter, there's a couple of different structures that do things very similar to this. I'm showing you try because it's part of the standard library. It's going to be the most common one. Validation, and then there's either, which is the more generic. It's a one thing or it's another thing, but I can't tell my left from my right, so I usually use try. Try, like list and option, has flat map and map. It also has filter. You just wrap the throwing code in a try. And if it succeeds, you'll get back a success. And if it fails, you'll get back a failure with the exception that's thrown, because that's often pretty useful. Notice that the type of a failure, even though it failed on the gas cap thing. The whole type of it's a failed engine, because that's all you care about at that point if you're calling the method. Oh, crap, something's not working in the engine. And then we can convert these, a nested series of these calls into a ForYield. In recover is a way it's basically a map on the failure side here. So this is cool. We get that throws blah, blah, blah exception effect from Java without having to like interrupt our execution flow in the same way, without having basically crazy go-tos everywhere. It's easy to add more checks, and like with option, we can put this into other ForYields and we can compose them. One thing that's really interesting here, and the reason why I'm showing you this, is that wrapping it itself does some work for you. It catches the exception. We saw the work that FlatMap was doing on list, and here there's work additionally being done in the initial creation of it. And it turns out actually option does that too. If you wrap something that can be null, it'll do that work of checking it for you. So that's pretty cool. The act of like that creation of turning a value into a monad, if you're gonna get all mathy about it, is often called like point or return. So yeah. Last one I'm gonna show you. So all of these calls could potentially block, right? Especially, I don't know if you ever talked on the phone with my mom, but that one is a potentially really expensive operation. And we can't let that stop our road trip, right? I just need grandma's address. So we want a way to deal with this, and we want it to be just as clean as the other ways we had. Hence a future. Despite Evan's warnings, I'm going to try to explain future to you. Like try here, though, the wrapper is doing some pretty substantial work. It's actually scheduling or spawning the asynchronous work, which is interesting. And here we're using the implicit default, and that uses threads, but you can also use actors for this, which is another wrinkle, and that's part of why the interaction between the two can be confusing. But again, whatever that boilerplate is, we've pushed it off to this magic import. So that's kind of the work that the wrapper does here. It schedules the work and spawns it. What does map and flat map abstract away here? Was there anyone else who's a JavaScript programmer in here besides Clint? Anyone else who's done JavaScript or started with JavaScript? How do you access results of asynchronous calls? Callbacks. What happens when you have more than one asynchronous call to deal with? Nested callbacks. Yeah, no fun. So what we're abstracting away with the ForYield and features is those nested callbacks, which I think is like, I mean, I got it with FlatMap on a list, but when I saw it on features, the work you now didn't have to do those nested callbacks, I was like totally sold. Notice here that like write postcard is going to depend on visit state completing, but some of these don't depend on each other. In this example, we visit Wyoming and we kick those off in parallel. We start looking for a post office the minute we're on the road, right? But we don't get the address till we're finished with the visit. There's some design issues here, which is why no one got any postcards on my road trip. But what I'm showing here is that you can do both parallel and sequential asynchronous work using a ForYield and futures in a way that's I would say this edges on the magic in a bad way. I actually think some of this is, and I think Evan can disagree, but I think that's what he was getting at. There's some subtleties here about what's being kicked off when that's a little intense. It's a little hard to deal with, but that abstraction, that powerful abstraction is something that we get out of the ForYield in the future. It's sort of rolled for us already, and I think that's pretty cool. So, to wind it up, some other M words that might be interesting to you. Iteratee is a really hot one right now. Iteratee is Iteratee is the play version, I think. There's always 6 versions of everything. Of handling streaming data, which is a really interesting concept. There's also, so Iteratee is a way of handling the stuff that's abstracted away is handling streaming data. Reader is one way. If you objected to traits as handling dependency injection, reader is a monad to handle that, which is really very, very much hard-coded kind of stuff. But, well, I don't know. I've had this argument before. So if people want to have the dependency injection and Scala argument with me at lunch, I'm so down. But reader is one way to do it. Writer is a way to handle logging. State is kind of interesting. It lets you compose functions and lug mutable state around without actually having, global mutable states. That's kind of cool. IO is one that I find conceptually interesting. It's straight out of Haskell, and in Scala, it is kind of a semantic marker to show that something you're doing has side effects, and you control the time of execution with it. It's an interesting idea. So, that's some stuff about the M word and ForYield. I'm going to wrap up with some sort of avenues for further exploration if this is interesting to you. Some objections you might have right off the bat for ForYield. I don't want to fail fast. Often you don't, especially if you're doing anything like user input. You often want to do all your validation in parallel and return the results of all of them so they don't have to be like invalid address, invalid zip code, invalid phone number. You can do that with things wrapped in a M word. There's a couple ways to do it. The one I'm most familiar with is using applicative functors, and functor is not a monad, and we can get into that as well. We call this home alone at my workplace. Can I use different kinds of monads in a ForYield? Could I have something that returns a future mixed with something that returns an option, mixed with something that returns a try? No, you can't. You can't, but there are various ways around that depending on the use case. It could be as simple, depending on whether this works for you, as doing 2 sequence. A lot of monads have a way of turning something into a list if that's all you care about. If you're getting more complicated with nested stuff, you can get into monad transformers, which are actually pretty cool, but it's more complicated. It's inside out. A lot of times you'll have an option of a list and you actually really just want like a list of those options, or vice versa. There are some, I'm calling them monad operations and they're not all on monad, so I apologize. There's some operations that you can do on monad type things that let you handle that automatically, which is pretty cool. So yeah, thank you. ForYield. And that's going to loop while we do questions, which I'm really happy about. Does anyone have any questions?
What kind of van do you have?
It's a Dodge Ram conversion van with like tinted windows. It is so creepy. It's a really creepy van.
I think I had a very similar van. It was awesome.
It's pretty badass. I need to replace the carpet. The shag's getting a little nasty, but... Mm-hmm.
Those examples, like it could be a future or it could be a try. Do you have any thoughts about how to make it more obvious?
I mean, there's always being really explicit about your types. So I don't have a return type here, but for example, I think for the Let's go back to the dinner one. When I'm writing ForYields, and I actually write, because we do asynchronous work with involving both actors and asynchronous HTTP calls, I find myself with nested monads quite frequently. My operation in writing a ForYield will often be to write out the return type at the top before I start, and then let the compiler do the work of telling me, that's not a dinner anymore, or whatever. So yeah. Yeah, type inferences often can be that kind of magic that is working against you instead of with you, so yeah.
Did you say WordNick?
Yes, it's called Reverb now. WordNick's one of our products.
Oh, okay.
We maintain Swagger and Scalatra, so if you've used either of those.
Does WordNick use Scala?
Yes and no. The site itself does not, but the backend does, yeah. We've got a lot of data, and we're doing some cool stuff that don't think I'm allowed to tell you about, but we can edit the video, right? No, that involves using some of that. WordNick is I don't know what we call it, I think the largest online dictionary. It's all user-generated data, and we're now looking at that data. We have a lot of data about how people use words, and we're using that to find out other things about what people want to read. So it's pretty cool stuff. We've got a bunch of NLP guys doing it, and we do all of that in Scala.
Do you all use the async macro at all? I mean, that seems to be like a kind of a cool new thing to be doing. It's not exactly like a for-comprehension, but obviously has some similarities in terms of transforming your code.
No, I don't even know what that is. So tell me more. No, I've not used that actually. I don't know much about macros. Someone should give a talk about that. Anything else? We're all ready for lunch? Yeah! Awesome. Thanks, guys.